Miss Chal, can you hear me? Shreya, can you hear me? Shreya Panchol?
Yes, ma'am.
Okay, thank you. Yes, next we are going to see how to find out the group number by writing this electronic configuration. Write the heading, rules for finding group number. Rules for finding group number. Number one, if the last shell contains 1 or 2 electrons, if the last shell contains 1 or 2 electrons, comma, then group number is 1 and 2 respectively. Then the group number is 1 and 2 respectively. Number 2, if the last shell contains more than 2 electrons, if the last shell contains more than 2 electrons, then the group number is total number of electrons in the last shell plus 10 plus 10. Number 3, if electrons are present in n-1 d orbital, if electrons are present in n-d orbital, in addition to those ns orbital, in addition to those in the ns orbital, then the group number is equal to, the total number of electrons present in the n-1d orbital and ns orbital. The n-1d orbital and ns orbital. So first you write the electronic configuration, then you arrange them into first shell, second shell, third shell, fourth shell, etc. And then you see what is the number of electrons in ns orbital, and if there is n-1d also. Let's see how to proceed. Atomic number 12. Atomic number 12. Write the electronic configuration. 1s2, 2s2, 2p6, 3s2. Now, ns means 3s. It contains only 2 electrons. So, if ns is having 1 electron, group number 1. If ns is having 2 electrons, group number 2. That is rule number 1. So, this is group number 2. Group number 2. Atomic number 12. 1s2, 2s2, 2p6, 3s2. Okay. If 3s has got 1, then group number 1. Now, if in this last orbit, if NP is also having electrons, for example, atomic number 7. Atomic number 7. 1s2, 2s2, 2p3. 1s2, 2s2, 2p3. Which is this element? Atomic number 7. That is nitrogen. Alright, that is nitrogen. So here you see NS has got, this is N, last shell N, right? This is last shell N. It contains S electrons and P electrons. So you add this total, that is 2 plus 3, 5. To this you add plus 10. Plus 10, that will be the group number. If the last shell contains more than 2 electrons, see, last shell contains, this is the last shell, it contains 5 electrons. If the last shell contains more than 2 electrons, then the group number is the total number of electrons in the last shell plus 10. That is 15th group. So 5 plus 10, that is 15th group. That is 15th group. Now, next point. What is next point? If electrons are present in n-1d also, see in this no d electrons. If electrons are present in n-1d also, in addition to those in the ns orbital, then the group number is equal to the total number of electrons present in the n-1d orbital and the ns orbital. For example, atomic number 25. One s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d5. Atomic number 25. Now, you organize it. How? 1 ka sare ek saath, 2 ka sare ek saath, then only you can come to know whether n-1d also contains. Exactly to know that. In for bigger number, you have to group it together. So 1, this is 1s2, 2, 2s2, 2p6, then 3. See, 1 3d is here. So you group it together. That is 3s2, 3p6, 3d5, then 4s2. In this way, you group together all the, see, 1, orbit 1 all together, orbit 2 all together, orbit 3 all together, then orbit 4. So this is ns. And you see in n-1 also, in addition to these 2 electrons, n-1 also contains d electrons. So if electrons are present in n-1d orbital in addition to those present in ns orbital, then the group number is what? This plus this. 5 plus 2, that is 7. 5 plus 2, that is 7. So this Atomic number 25, that is in 7th group. In this way, you have to find out the group number. Group number. So, you can find out the group number. First, you write this electronic configuration, then group together. Then you group together and see how many electrons are present in NS. Is it 1 or 2 or NP also? NP also, if it is in P also, then you have to, in the previous case what you have seen, you have to add 10. You have to add 10. Total number of electrons in the last shell plus 10. Last shell plus 10. Okay, that's about the finding of groups. Now, classification of S block, P block, D block, and F block. So elements are classified in the periodic table into 4 different categories: S block, P block, D block, and F block. S block. What are the characteristics of these elements in S block? You know, first and second group, they are called S block elements. Here, S orbitals are progressively filled. General electronic configuration is NS 1 to 2. NS either 1 or 2. They all are metals. Hydrogen is non-metal. Hydrogen is in the first group. Still the controversy is there of the position of hydrogen. It has got 1 electron in the last shell, means first shell. So it is kept in first group. But if it gains 1 more electron, it will be attaining the nearest noble gas configuration, that is of helium. Helium is in P block. So just like the halogens, they could also be kept in the 17th group, as you learned in class 10. So S block, general electronic configuration is NF 1 to 10. One exception is there. They are metals. Generally, they are metals. They have 1 or 2 electrons in the outermost shell. Means they have a tendency to lose this 1 or 2 electrons and attain the nearest noble gas configuration. Lithium has got 1 electron in the outermost shell. If it loses that 1 electron, it will be attaining the stable configuration of helium. Similarly, sodium has got 1 electron in the outermost shell. If it loses that 1 electron, it will be attaining the nearest noble gas, that is neon. So these metals, S block metals, they will be losing their outermost electron. They have either 1 or 2 electrons in the last shell. So they will be trying to lose that 1 electron. Or for us, it is very easy to remove that 1 electron. The amount of energy that we supply, or the amount of energy that is required to remove that electron from the last shell, that is called ionization enthalpy. So these S block elements have low ionization enthalpy. Low ionization enthalpy. That is the amount of energy required to remove that 1 electron or those 2 electrons. They have very low ionization enthalpy. For example, in the case of sodium, Na, if you give 496 kilojoules per mole, Na will lose 1 electron and it becomes Na plus. So they have very low ionization enthalpies. And they form, after the release of 1 electron or 2 electron, they form the cations. So they form ionic compounds. They form ionic compounds. They form ionic compounds. So these are the characteristics of S block elements. S orbital is progressively filled. General electronic configuration. S orbital is progressively filled. General electronic configuration. Outer electronic configuration. NS 1 to 2, 1 or 2. They have low I dot E ionization enthalpy, means you can easily remove one electron from the outermost shell. And the last loosely bound electron, the last electron, that is the electron to be removed, or we call to remove the first electron from the last shell, the last orbital, that is called ionization enthalpy. First ionization enthalpy IE1. IE1. The second electron to remove how much amount of energy that we are giving, that is called the second ionization enthalpy. Anyway, S block elements, they are having bigger size in a period. Last year you learned in a period, alkali metals are having the biggest size, or alkaline earth metals are also, alkali and alkaline earth metals are having bigger size. Bigger size means the last electrons are not very well attracted by the nucleus. You can easily remove that electron. The amount of energy that we supply to remove that loosely bound electron, the most loosely bound electron from the last, that is called ionization enthalpy. And these S block elements being bigger size, they have very low ionization enthalpy. So one electron or two electrons can be easily removed, and what is remaining, that is positive. So it can combine with a negative. For example, Na plus can combine with a Cl minus to form NaCl. These are ionic compounds or electrovalent compounds. Next, P block. In this, what are the characteristics? P orbitals are progressively filled. P orbitals are progressively filled, and their last outer electronic configuration, that is NS, NS2, N1 to 6. NS2, NP1 to 6. This is the last electronic configuration of P block elements. So in the last shell, that N is filled, that is NS2, then the electron enters to the P orbital. P orbital can contain 1 to 6. So group 13 to 18, they are P block elements. So here first is P orbitals are progressively filled. General electronic configuration we have written, that is NS2, N1 to NP1 to 6. NS2, NP1 to 6. They are mainly gases on that side, that side of the periodic table. Nitrogen, oxygen, chlorine, fluorine, these are gases. So they are mainly gases. Now in the case of S block, we said ionization enthalpy. In the case of P block, we call it as, in the P block, we say electron gain enthalpy. Instead of ionization enthalpy, as in the case of S block, here we say electron gain enthalpy. See, in S block elements, we remove one electron, here 2 electrons. In P block elements, they accept electrons. So when they accept electrons, some amount of energy is released. When they accept electrons, some amount of energy is released. To remove one electron, some amount of energy is required. These are the two opposite processes. So for example, if chlorine takes 1 electron, what will become? Chlorine was neutral by taking 1 electron. 1 electron means negative charge. Now after taking that negative charge, the species became negative. For example, Cl neutral, when it takes 1 electron, it becomes Cl minus. It becomes Cl minus. During this taking of 1 electron, some amount of energy is released. How much amount of energy is released? That is called electron gain enthalpy. So in this case, how much amount of energy is released? That is minus 349 kilojoules per mole. Top, this is plus 496, that is required. Minus means this is released. So 349 kilojoules per mole is released. Released means minus charge. Required means plus charge. So this is what is known as electron gain enthalpy, the amount of energy released when a neutral gaseous atom takes one electron to it, that is called electron gain enthalpy. So they will be taking electrons and release energy. Okay, so p orbitals are progressively filled. General electronic configuration, they are mainly gases. Electron gain enthalpy is released when they take one electron or two electrons, and they form covalent compounds. They form covalent compounds. They form covalent compounds. Next is D block elements. What are the characteristics of D block elements? For D block elements, actually this D block is in between S block and P block. It's a transition from more active S block elements to less active P block elements. So we call D block elements as transition elements. It shows a transition between what? From highly active S block elements to less active P block elements. So a transition, to show this transition, we put this D block elements. So we are calling this D block elements as transition elements. It's a transition, a change, a slow change, a transition from highly active element to less active element. So these D block elements are also called transition elements. And D orbitals are progressively filled. Of course, the last electron enters to a D orbital. Now, what is the general outer electronic configuration? That is n minus 1, D 1 to 10, and ns 0 to 2. This is the general electronic configuration. They show variable valency. They show variable, the D block elements means scandium to zinc, yttrium to cadmium, and lanthanum to mercury. 3D transition series, scandium to zinc, 4D series, 4D transition series, that is yttrium to cadmium, and 5D transition series, that is lanthanum to mercury. Scandium to zinc, yttrium to cadmium, and lanthanum to mercury. These are the 3 transition series. 3D transition series is also called first transition series, 4D second transition series, 5D third transition series. These all are metals. They show variable valence means +1, +2. For example, Fe shows +1, Fe shows +2, Fe shows +3. +2 is ferrous, +3 is ferric. Copper shows variable valencies +1 and +2. That is cuprous and cupric. +1 is cuprous. Smaller one is Us, bigger one is Ic. So copper +1 is cuprous, copper +2 is cupric. So they shows both, that is variable valencies. So generally D block elements show variable valencies. Mn shows +2, +3, +4, +5, +6, +7. So many valencies Mn is showing from +2 to +7. So these show variable valencies. They all are metals and they have many unpaired electrons in their electronic configuration. You see many unpaired electrons. If there are unpaired electrons, they will show magnetism, means they will be attracted towards the magnet. So we call it as they show paramagnetism. They show paramagnetism and they form colored ions. Colored ions means you know, copper sulfate. Copper sulfate is blue in color. Iron sulfate is green in color. Cobalt is jamun color. That is somewhat violet type color. Then what? Many are colored. Nickel is emerald green, nickel carbonate or nickel chloride or nickel nitrate, they are green in color. So they show colored ions. They show colored ions. Fe2 plus green in color, Fe3 plus brown in color. So these form colored ions. Okay, and they can be used as catalyst. Last year you must have learned hydrogenation of vegetable oil to form Vanaspati ghee. In that we wrote nickel, palladium or platinum. Hydrogenation of oil, H2PD, yeah, H2PT or H2Ni. So these are nickel, palladium, platinum, these are used as good catalysts. These are all D block elements. So what are the general characteristics of D block elements? First one, D orbitals are progressively filled. D orbitals are progressively filled means the last electron enters to a D orbital. General electronic configuration, that is n-1d 1 to 10 and ns 0 to 2. They show variable valencies. They are metals. They are paramagnetic in nature. Paramagnetic in nature. They form colored ions. Number 6, they form colored ions. They can be used as catalysts. So these are the properties of D block elements. Next comes to F block elements. Again, F orbitals are progressively filled. They are mainly radioactive elements, so their studies are very difficult. So about F block, there is not much studies carried out. They are radioactive and they show variable oxidation states. F block elements. For F block elements, again, F orbitals are progressively filled. They show variety of oxidation states. Their studies are complicated because they are radioactive and they show variety, a large number of oxidation states. Elements after uranium, F block means that down portion. Elements after uranium are called trans-uranium elements. That's about the classification to S block, P block, D block, and F block. Thank you.